Alright, there's going to be times when you are talking about area and an area between curves. Well, sometimes it's just easier if we just solved and made y our independent variable. So let's say f and g are continuous on a to b, and that the y-coordinate for f is less than the y-coordinate for g. And we're talking about, instead of vertical lines, we're going to be bounded by horizontal lines of y equals c and y equals d. Then the area found for a between two different curves is from C to D of your larger, the one on the right, minus the one on the left. So you want to note, if your area is more on the, it's easier to do right-left than you really want to use with respect to y. Alright, number 1, consider the curve y squared is equal to 4 plus x, and the chord AB join the points A of negative 4, 0, and B at 0, 2 on the curve. Find the area of the region R enclosed by the curve and the chord AB. So let's go ahead and let's do a quick drawing. I'm going to go ahead and solve for x. And so x is now my dependent variable and my y is now my independent variable. So that becomes, where I have y squared is equal to 4 plus x. If I solve for x, that means I'm getting x is equal to y squared, and if I subtract 4 from both sides, I get minus 4. And so if I was graphing this, it's very similar to a parabola, except for we're going to be a parabola opening up toward the right-hand side. So our parabola is going to look something like that, but it's opening up towards the right. If you want to think about the y-intercept, sort of, is that negative 4, except for now it's our x-intercept. And so if I plug in 0 in for x, I'm going to get y is equal to 2 and y equals negative 2. So now I'm going to draw the chord, and so I have a point at negative 4, 0, and I also have a point at 0, 2. And so you can figure out where our points of intersection are going to be. And so I want to go ahead and get the equation of the blue line, and so I know my b is going to be 2. My m is up to right 4, so that's 1/2. So we're talking about y equals 1/2 x plus 2. So again, I want to solve for x, and so if I have y equals 1/2 x plus 2, we'll subtract 2 from both sides, I get y minus 2 is equal to 1/2 x. If I multiply both sides by 2, my 1/2 will cancel. I'm just left with x. And I'm on the left-hand side, I'm left with 2y minus 4. So x is equal to 2y minus 4. And so you're wondering, why are we solving for x? Well, the reason why is we want all of our variables to now be in y form. So at this point, it would be easier, instead of doing up and down in terms of x, it would probably have been easier to do in terms of y. That way you don't have to worry about a square root and then you have to use a chain rule. This makes it a lot easier for you to do. Otherwise, we would have the square root of x plus 4, and I don't think you would like to work with that. I know you guys hate that kind of stuff. So trust me that being able to solve for y makes our life a little bit easier. You can see from our bounds that we're going to start, well, we're not starting at the x coordinate, we're going to start at our lowest y coordinate. So in this case, my lowest y is 0. My highest y is located at 2. And so now I'm going to subtract my right-hand function, which is in blue, from my left-hand function, which is in red. So I'm going to do blue minus red. So blue, when I solve for x, is 2y minus 4. And now I'm going to subtract my red function, which is y squared minus 4. And this whole thing is multiplied by dy. So when I simplify this, I'm going to get from 0 to 2, 2y minus 4 minus y squared plus 4 times dy. And you'll notice your 4's are going to cancel. So I'm just going to have the antiderivative from 0 to 2 of 2y minus y squared times dy. So the antiderivative of 2y is y squared. Antiderivative of y squared is y to the third over 3. And we'll be evaluating that from 0 to 2. So at this point we can just go ahead and plug in. So 2 squared is 4 minus 2 to the third divided by 3. And we're subtracting, if I plug in 0, I'm still going to subtract 0, so I'm not really worried about that part. So I have 4 minus 8 thirds. Well, that's like saying 12 over 3 minus 8 over 3. And so that gives me 4 thirds. And that is the area between the two curves. So now let's go over to number 2. So if we want to find the area between y equals x and y squared minus 6 is equal to x, they've already set it up for us. We already know that x, let me do it this way, same colors, x is going to be equal to y. That's one of my formulas. And the other one is x is going to be equal to y squared minus 6. Well, if you want to know where they're going to intersect, you have to set your two functions equal to each other. So I'm going to set y is equal to y squared minus 6. If I subtract y from both sides, I get 0 is equal to y squared minus y minus 6. And I'm going to go ahead and factor. So I get y, factors of negative 6 are negative 3 and positive 2, and that allows me to have y is equal to 3. Or y is equal to negative 2. So when I graph this guy, again I have an x-intercept of 6. 1, 2, 3, 4, 5, 6. So we have the function y equals x. That's that guy. And they're going to cross at y equals 3. So that means that we're going to have an intersection at 3, 3. And negative 2, negative 2. And so our x-intercept is at 6. And so this is what our function is going to look like. And so we could do top minus bottom, but it's a little bit easier to go ahead and do left minus right. And so my right minus left. So my right function is in red, my left function's in blue. So I already know where they're intersecting. I know they're intersecting at my lowest y, which is negative 2, and then my highest y, which is 3. And so I'm going to do my red function, which is y, minus my blue function, which is y squared minus 6. That's all terms of dy. So we have negative 2 to 3 of y minus y squared minus 6. That's all times dy. So we're ready to take our antiderivative. So this gives me y squared over 2 minus y to the third over 3 minus 6y. And that whole thing is being evaluated from negative 2 to 3. So if I plug in 3 squared is 9, so I have 9 over 2 minus 3 to the third is 27, so I have 27 over 3 minus 6 times 3, which is 18. And then I'm going to subtract that by my negative 2. So negative 2 squared is 4, so I have 4 over 2, minus negative 2 to the third is negative 8, divided by 3. And negative 6 times negative 2 is positive 18. And so if you simplify all this, you're going to get, whoops, I made a mistake, sorry about that. This is supposed to be 12. Sorry about that. Alright, so now, sorry about that. So when you put it all together, just go ahead and use your calculator. You're going to get negative 235 over 6.